In our previous video, we just talked about graphing sine and cosine just as is without any sort of transformations. Now, the goal of the remainder of this video is to graph sine and cosine with any sort of transformations. So any sort of shifts left, right, up, down, reflections, a change in your period and your amplitude. So we're gonna graph 6 more. So these are the 6. If you'd like to pause the video and try it on your own, we'll be talking about creating this answer key. Now, your amplitude we talked about in this previous video being the height of each wave. This being the number that is found over here, directly attached to your sine or your cosine function. This value is going to either stretch or compress your graph vertically. So your amplitude is always the absolute value. It's the height of your wave, which we can't have a negative height. So we're always going to take the absolute value of this number. So this being the absolute value of 2. Now, when it comes to your period, typically your sine and your cosine travel around your unit circle, and we start at 0 and we travel all the way around to 2 pi before your values start to repeat. Now, if there is any sort of adjustment to your period, that is going to be a horizontal stretch and compression, and that comes from having a number that is directly attached to your x. Now we're going to take this number 1/2 and call it k. Now to find your period, we typically say this is 2 pi and now over this k value. Our k is 1/2, so we're going to say 2 pi over 1/2 is now 2 pi times 2 over 1, or 4 pi. So now it is going to take an enormous amount of time for your sine graph to now complete a full rotation. Now, when it comes to a reflection, your reflections, if it's found on the outside, is going to be your negative here. That's why we always take the absolute value. So if you don't see a negative on the outside, we don't have any sort of reflection. Now, phase shifts are found on the inside of your parentheses. Typically, this will be added or subtracted on the inside of your parentheses here. So we do not have anything added on the inside, so we have none. A vertical shift happens on the outside of your function. So notice that there's nothing being added or subtracted, so therefore we have none. Now, when it comes to your graph here with your sine function. So keep in mind, actually, do I want to do that? Keep in mind, typically this is what your sine graph should look like. However, now what we're going to do is we're going to take, hopefully I can take this graph. Let me try that one more time. If I just copy, let me paste the whole thing. Ah, so if this is what your graph was originally, right, we're going to take this function and we are going to stretch it vertically up by 2. And then what we're going to do next is that all of your values here along your x, these values are going to change. So if we complete one full rotation, so one full rotation, instead of taking us 2 pi, is now going to take us 4 pi amount. That means at the very end of this rotation, this revolution, we have now completed all the way to 4 pi. So that just means that half of your period, well, half of pi over 4 is 2 pi. And half of this amount here, so half of 2 pi is pi. In between, so if we're going from this point to this point is a matter of pi and another pi and another pi, we have now 1, 2, 3 pi's amount. And then that extra pi will be our finishing. So if we don't have any sort of shift left, right, or up or down, we can take your original graph and manipulate it based on your period and your amplitude. So we now have a stretch of 2, and that's again the height of each wave is going to be 2, and it takes us a whole 4 pi now to achieve a full revolution. And again, I'm going to adjust these negative values over here to show it on the other side. So this would be negative pi over 4, negative 3 pi, negative 2 pi, negative pi, and again, 0. Now let's try your cosine. So your cosine, your amplitude, we do see a negative value, but this is really the absolute value of negative 1, which is 1. Now your period, if nothing is found on the inside directly attached or multiplied to your x, our period will remain the same because your k value is equal to 1. So if we have 2 pi over k, we just have 2 pi over 1, which is just 2 pi. So one full revolution is going to take us 2 pi. Now we do have a reflection. Your reflection comes from that negative. So we have a reflection over the x-axis. Let's see if we have a phase shift. That's going to be found on the inside of your parentheses, which we have none. We do have a vertical shift, though. We are going to be shifting your cosine graph up by 3. So let's take this graph here first, just for starters, and we'll manipulate it. So if we originally had this graph, again, we're going to be still having a full revolution of 2 pi. Your waves are still at 1. However, we're going to take each of these values and reflect it. So when we go to reflect over the x-axis, all of these values are going to be coming down, and all of these values are going to be coming up. Anything that remains on the x-axis will remain unaffected. So I will have to redraw this, but I did want to get my parent graph on there at least once to just show you that we are going to be adjusting this one slightly. Now I'm also going to shorten my graph because we are going to be transferring our graph up a few units. So I'm just going to adjust my waves so that they are just a little bit smaller. I'm going to keep everything else the same. So we're going to go up by increments of pi over 4. So we start up, down, down, up, up. So this was one full revolution. Oops, I went too far down on that one. Too far down, there we go. So this is one revolution with your cosine. Now we are going to take each point, as we talked about before, and adjust it so that each point will be reflected over your x-axis. So these points will adjust. So now this graph in purple is a graph that has been reflected over the x-axis. And we are going to take each of these points and push them up 3. So 1, 2, 3, this is your new point here. 1, 2, 3, this is your new point. 1, 2, 3. So our graph should now look like this. Now, because we did need your x-axis to kind of show us where these values were going, we do want to make a pseudo x-axis. There you go. So that used to be that's our new quote unquote x-axis. So again, the height of each wave here is going to be a total of 1. Our unit, our period is still 2 pi. So we ended at 2 pi still. All right, so let's try it again on your next ones. So now let's see what we do if we have a phase shift. So on number 5, again, I'm going to grab my sine graph here. Copy. Oh, I guess I didn't actually get to copy it. One more time. Copy. There we go. So I'm going to be using my sine graph to kind of just help us get it started. So when it comes to your amplitude, so see if actually you can pause the video and try these first few. Your amplitude is going to be 1 here. Your period is still going to be 2 pi. Your period is always going to be something that's multiplied to your x. Now, typically, you want to make it so that if you do have any sort of phase shift, that if there is a number that's multiplied here without any parentheses attached to kind of separate it, that we do have to factor it out. In our case, I'll make it so that they're all factored out in one way or another. I don't think I have an example of it, but you do want to make sure that any sort of horizontal stretch or compression is found on the outside. So there should be some double parentheses here is what I'm trying to suggest. Reflection, we don't have any. Phase shift, we do have a phase shift. But with your phase shift, notice that we do have something on the inside of this parentheses. Now, if it's negative, or what looks to be negative, it's really going to be positive. You can do this by setting it equal to 0, adding pi over 2 to the other side to see, okay, well, we are going to be adding pi over 2 to all of your x values. So your phase shift, we're going to move to the right. That's where your positive numbers are, to the right, by pi over 2. Your vertical shift, there's nothing being added on the other side, so we have no vertical shift. So we are going to take this shift over here. So take our graph. So again, no funny business with your graph. And what used to have all of these x values here at 0, at 0, at pi over 2, at pi, at 3 pi over 2, and 2 pi, we're going to take each of these special points and we're going to add your phase shift. So at 0, we're going to add pi over 2. At pi over 2, we'll add pi over 2. At pi, we'll add pi over 2. At 3 pi over 2, we'll add pi over 2. At 2 pi, we'll add pi over 2. Again, if it's talking about a phase shift, these are all going to be affecting your x values. Whereas if it is a vertical shift like we had here, we went up 3, well, it only affected your y values. Notice that your x values here, they didn't get, they weren't affected. I think they were started right here, right? They weren't affected, right? Your x value was still here at 0, 1. It's the y value that went up 1, 2, 3. So we're now at 0, 3. So when it comes to a phase shift, we affect your x values. So you take each x values that's showing, and we're going to add your phase shift to each of them. So in our case, our new 0 value, and I might even have to push this up. Our new values here. Put that there. Our new value, so if we had 0 plus pi over 2, this 0 here, which used to be found, if this 0 was on your x-axis, when we add by pi over 2, it's now going to move its position to over here. And you'll notice that the pi over 2 amount was up high originally, and now it looks like it's down low. We're going to do the same thing. The one that was up high, when we add pi over 2, it now shifts to pi. So now it looks like the pi value that was down low is now up high. So that's what we're going to do for here, is that pi over 2 is down low here. We have up high, and I'm going to have to erase your period here to kind of fit everything in. Your period here, let's see, right there. At pi. Oh, and I might need to scoot it just a little bit more. 3 pi over 2. At 3 pi over 2, we were, nope, I did. Oh, I forgot my pi. So down low here at pi, we're here. At 2 pi, we're now down here. Oh, here. And then we're back here to the center. So this new one at pi over 2, 4 pi over 2 plus pi over 2. So then we're now at 5 pi over 2. So that is where this new value is, at 5 pi over 2. Now, if you wanted to as well, you can shift over some of these values that were on the other side of your x value, or of your x or y axis. So if you did add pi over 2 to some of these values, so negative pi over 2 plus pi over 2 is now at 0. So at this value 0, we now have this point that got shifted over. We're up here, got shifted over. So when we talk about your cycle, if this one goes off the page, your full revolution here will be this revolution here. Again, so all of your other values kind of get shifted over. Again, you could do so by subtracting or adding pi over 2, adding pi over 2. So this is now pi. So at negative pi, we're up high. At negative 3 pi over 2, we should be down low. At negative pi over 2, we're down low. And you're seeing that right here as well. All right, so these are our new, this is your new graph. So again, all you're going to do is you're going to take your old graph points and you're just going to add by that phase shift amount. Keep your y values the same, but change your x values. So again, you'll notice that if I were to put this graph on top of the other, so that's my shift over here. And if I'm adding by a pi over 2 amount, that just means that all of these x values will shift, but your y values will not. So without any sort of phase shift, and then a phase shift. If you added by a pi over 4 amount to the right, it would be over here. Or if you subtracted, it would go this way or that way. And you'll notice that some of these graphs, they're going to be making, you can make a cosine graph out of it as well. I'm going to try as hard as I can to match that up. There. Okay. So now let's try it again with your cosine. So let's go ahead and grab my cosine graph. See if it might be helpful at all, kind of like what we just did a moment ago, kind of showing you that shift. All right, so now let's have you pause the video and try to graph this cosine graph, or at least find these particular values. Your amplitude is 1. Your period, if k is that number directly attached to your x, so k is equal to 2. We have 2 pi over k, which is 2 pi over 2. Our period is now pi, so we've now shortened our graph. Reflection, we don't have one. Phase shift, we don't have one. However, we do have a vertical shift. We're going to go down by 4. So if we were to take a cosine graph, which your cosine graph, and I'm going to change it so that now all of my values are at 1. So cosine, let's see, my period, yeah, that's okay. So if my cosine graph here, there we go. If this is my cosine graph, right here, if typically my graph is 2 pi, if I now shorten it, so now my period, instead of being 2 pi, I want to end it now at pi. That just means that at this value, this is pi, meaning that half of my period is pi over 2. And half of this wave here is pi over 4, which means that each of these values, so going from here to here, is about pi over 4, 2 pi over 4, and another pi over 4. So pi over 4 plus, pi over 2 plus pi over 4, right? Getting a common denominator, not a common denominator of 4, common denominator of 2, right? We should get 3 pi over 4. So that's how we can get some of these values. Pi, if we did the same, pi is just 4 pi over 4. So we can kind of keep the same workings of your graph, but just by changing some of those x values. So now your period is 2 pi, or sorry, pi over 4. Nope, and your period is pi. There we go. Sometimes I cannot multitask at the same time. So your period here is 5. We said your amplitude, the height of each wave is at 1. So these heights should be at 1. And now we're going to take each of these values and then shift them down by 4. So take each value and shift it down 4. So 1, 2, 3, 4. And I'm definitely going to go off my page. So if I am going off my page, let's see, I'm at 0, 1, 2, 3. So that's -3, -4, and -5 here. I want to connect my dots. And here you go. Again, I want to make a pseudo x-axis to say this was where my zeros were occurring. And there you go. There is our cosine graph. And again, we're just going to be graphing one full revolution. Let's try it again with these two. I'm hoping that you're going to pause the video and at the very least, find these values here. So let's do -3 sine of sine plus 2x. So your amplitude here is the absolute value of -3, which is 3. Your period here is 2 pi. Your reflection, we do have one over the x-axis. Your phase shift, we have none, but we do have a vertical shift of up by 2. So we're going to take our sine graph, which we're going to just graph a quick parent graph. Here's my quick parent graph of sine. So we have pi over 2, pi, 3 pi over 2, and 2 pi. And we're going to stretch first. Well, actually, let's do our reflection first. So let's reflect all of these values. So what comes up must go down. So now we're at here. So this is my reflection. Maybe I do that with a different one. So this is my reflected graph. We now get to take all of these points and we're going to shift them up by 2. So we're going to go up by 2. 1, 2. That's my new one. 1, 2. And this is my new sine graph. Again, making sure that these x values are known. And then your y values, we're going to give some context. So this is 1, 2, and 3. Not all of your graphs have to be so ginormous like mine. Sometimes they can be a lot smaller. Let's do number 8. So your cosine is 1. Your period is still 2 pi. You do not have a reflection. You do have a phase shift. We are going to go to the right by pi. And then we have no vertical shift. So let's take your cosine graph, and I might just take this cosine graph here that we graphed before. Oh, come on. One more time, maybe. Copy. Paste. All right. So I'm going to take my cosine graph from before and just plot it right on here. And now, because everything is going to remain the same as far as an amplitude and your period, we can keep it as is. But now we're going to take each of these values and go to the right by pi. So that just means that each value here that we have listed, and because it's a phase shift, it's going to it's going to change all of our x values. So we're going to add, or sorry, this time we're going to subtract pi, and actually it's not to the right, it's to the left. to the left by pi, and that's why we're going to subtract. So we'll subtract pi to each of these, and then we'll come up with new values. And if we want, we can do it to the other side too. So all of these values, so your new value up here at pi, or at 0, is now going to be at negative pi. So up pi, so all the way at negative pi, so we're going to be up here. And notice that we were down low, and now that's going to be the opposite. And I'm thinking, do I want to change all of my values here? I think so. I think I'm going to put this graph right on top so that you can see that phase shift. I'm going to put it maybe right here. Oh, or maybe I get rid of it altogether, and then I'll just show you before. So we had 0, we're going to subtract by pi. We had pi over 2, subtract by pi. We had pi, subtract by pi. We had 3 pi over 2, subtract by pi. And one more, 2 pi minus pi. All right, so now for this one, we should be at negative pi. Let's see, if we want 2 pi over 2, we're now at negative pi. Hold on. Yep, no, negative pi over 2. We're at 0. We're at, let's see, 2 pi over 2. We're at pi over 2. And then we're at pi. So these are your new x values that we're just going to put on here. So we're at negative pi. So let's see, our old graph, I think we did like this. I want to keep those values the same, just so that if I put it on top, you guys can see where, how similar it looks from previously. So if before, if for your cosine, right, we were up high starting at 0, and we've now have a new x value, or a new x value at negative pi, we're going to take this value that was up high and transfer it over here. And same thing with your cosine, your next value came down low, and now we're at negative pi over 2. So now our next value should be down low. And then after pi over 2, at negative, or at pi, we were back down really low. So now at 0, we're going to be low once more. And then we're going to go up high. And then all the way up. So this is what your new graph should look like. And I'm going to put it in maybe this pink color. Or no, maybe a blue. This is what the new graph's full rotation should look like. And notice that each time I'm doing this, I have 5 points here. And I'm just going to extend it out so you can see a full point. So now when I put my original graph back on, you can see there's going to be, oh, come on, don't make me do it one more time. You can see the full phase shift in effect. So what we get to do is we take this original graph, let's see, paste it back on there. So if this is my original graph, right, the one in black, if I take this original graph that's in black, and if I shift it to the left by pi, notice how I'm going to be moving these values here all the way over by pi. And it should line up just as we have it over here. If we were to move it to the right, we're just moving those x values to the right by that pi amount. Now we can always move it not by pi or pi over 2. We could move it by pi over 4, pi over 6, pi over 3. And you'll just notice that your phase shift is affecting your x's, whereas your vertical shift is affecting your y values. And that's going to conclude our video for today.